Marcus to come back, because this is, after all, Fringe is his show more than anyone else's, isn't it? Should we start without him?
He doesn't care about that. So
Does he?
It's,
okay.
It's okay.
Well, in the interest of running on time, it's 11:30, so we've got the session summary from the Sentinel-1 opening session, so please take it away.
Yes, thank you. So very briefly, so it was an overview session where we showed the status of the Sentinel-1 mission and the schedule for Sentinel-1C, the status of our Calval activities, data quality monitor. We also provided some details on the monitoring of baseline and burst synchronization, which are currently slightly impacted by the increased solar activity, and also shown some recent evolutions which are more relevant to interferometry, like the burst ID map, and also the RFI correction, which we have activated in 2022. And we have also shown how this is impacting interferometry. The main recommendations that we gathered at that session and some parallel discussions connected to it were to reprocess data, especially from the beginning of the mission, the 2014 and 15, which are somehow degraded in quality and possibly impacting the quality of certain applications. In general, to reprocess archive data, making full use of the newest algorithmic developments and ensuring the homogeneity of the data. I think the complementary recommendation of that will come in the next session, which was more into the direction of giving the level 0 and the processor, so that's why it's not in this one. Then also there was the recommendation to provide data, being it really products or annotations, which have only been recently started, things like burst ID and etat products, but also for the entire archive, to reprocess some data with known anomalies, in this case specifically for the burst ID annotation, to foster the characterization of RFI signals, for example, by creating databases exploiting information which we might extract from our own detection and correction approach, to extend the data quality flag, in particular with respect to orbit quality, and also to improve the communication of major anomalous data processing events. So that's all I had from that session. As I said, there was a lot more discussions concerning processors, availability, and level 0, and I believe this is also coming in the next session recommendation.
Perfect, thank you very much, and brilliant sticking to time, despite the rapid-fire 6-minute per presentation in this summary here. So next up, we've got the SAR geodesy, and atmospheric and ionosphere. Are we combining them two together? We're combining them together. So could I invite the roundtable rapporteur up to present on that? Do we know who it is? Where are they? Well, maybe we'll skip over. We'll jump, but we'll have to come back to them potentially if we can identify who they are. So then next up, after we've got that, is data products and services. So who is the session chair that will be presenting on that?
I think that summary is missing as well.
We are going to be firing through this whole session. You're going to get home early, and there's going to be a luxury long lunch break. So next up, we've got future INSAR for ESA. There we go. Come on in. Fantastic. So gold stars for Sentinel-1 and future INSAR at ESA.
Yeah, so thank you, Anna. I don't take all the time I get now from two presenters not showing up. Just very quickly, I think it's not like a big summary needed here. So we had four presentations, one on biomass, then one presentation on ROSE-L, Sentinel-1 Next Generation, and one on Harmony, and another one on Harmony on the end-to-end for the land applications by POW. So for biomass, there was some discussion later on for the polarization. Also, we had a polarization question for Sentinel-1 NG and ROSE-L. So just to repeat here, the orbit time will be the limiting factor, and it's open to consideration how to use quad pol data for the satellites. Then we discussed a bit the ionospheric mitigation and L-band, and I'd like to advertise here again that we are issuing an ITT for an ionospheric study very soon. Then we had some information about the burst overlap for 3D deformation retrieval. The two-look scatter for Roselle was discussed, and just also to remind that modes will be generally limited for both of the missions, like it was already for Sentinel-1, to a strict minimum, and it will also serve the different user needs. Maybe something which I realized here during the meeting, that it was mentioned a few times, that the spacing between Sentinel-1 Next Generation and Roselle will be 3 days. That's actually not decided yet. So if you include this in your recommendations, it's very helpful for us, because there are other communities rather looking into convoy concepts, like for instance the sea ice community. But I understood here that the advice would be like a 3-day spacing with Roselle, Sentinel-1 Next Generation. For Harmony, we discussed a bit on the level 3 products and the algorithms, and also here, although it's like an Earth Explorer, we try to be open to the community, and everybody should be able to use the data and the algorithms in the future. So I didn't have a lot of time to finalize the slides. So then we discussed a bit about useful parameterizations for the mission, and also the capability of theoretically Harmony to fly with Sentinel-1 Next Generation. We are investigating this, it's not the baseline, but just to remind, Sentinel-1 Next Generation will also be companion friendliness. And then I mentioned the last talk from Pau on the performance analysis for the land applications for Harmony. I don't know if you want to add anything. I didn't have anything from the discussion, so everything is perfect here. And since I have another meeting very soon, I decided to change the agenda slightly, and I continue with the C and L-band synergies session that we just had this morning, together with JAXA. So Takeo Tadono from JAXA is here, who co-shared this session with me. And for everybody who did not participate in the session, so we initiated this cooperation to acquire L-band data to be used in synergy with Sentinel-1 data to further or better understand the synergies and limitations of both of the missions and the different frequencies. So we are also running a few studies in parallel to really help the development of Roselle and ALOS 4. So we had one presentation here from Andre on surface deformation in a mining area, and the focus was on ground motion, on PS density analysis, which really increased in rural areas with ALOS 2 data compared to Sentinel-1, and also a similar long-term positive trend for the time series analysis could be seen. The problem is here a bit that it takes some time to get a good time series available, because the ALOS 2 orbit is a bit limited, so we don't have a lot of acquisitions. And we are really looking into ALOS 4, or expecting to have a much better repeat with ALOS 4 data, or even then NISA in the meantime. The second talk would have fit very well already in another session, because it was on soil moisture derived from INSA and phase closure. So also here, C and L-band data were compared by Francesco. And he studied the backscatter and coherence in the different frequencies, and the correlation of INSA-derived soil moisture with land surface temperature, which I believe nobody has done before, and also with optical images from Sentinel-2, and that also the same features were visible in the Sentinel-2 data compared to INSA-retrieved soil moisture. This might be interesting for weather forecasts in the future. Then we acquired this LS2 time series over 3 years in Puglia in Italy, where we also have a good ground truthing because it's over test fields. And there are good results over undisturbed terrain, but more research is necessary to really use the data. Then we had a presentation by Takeo Tadono from JAXA about the status of the ALOS2 mission and the Calval plan for ALOS4. So we had a status of ALOS2 and an overview of ALOS4, some example applications, and also It was emphasized that the collaboration with international agencies and private sectors, it's extended by JAXA, so they are collaborating with us at ESA, but also with NASA and CSA and ASI, so in many different directions. And then there was a question on the minutes per orbit of ALOS 4, which will be roughly 50 minutes. Then there was a recommendation, I come to this later again, but for more acquisitions in this L-band collaboration for Antarctica and Greenland with different snow types, so dry and wet snow, and also different topography. And that it would be good to organize like a joint collaboration validation campaign for an Arctic or Antarctic site. Then we had another talk from a Japanese colleague, Ryosuke Inabe, a case study for ALOS 2 emergency disaster prevention for slope failure in Japan. So we got a good overview here of a landslide study using ALOS 2 data and how Sentinel-1 data could be used. So the coherence in the Sentinel-1 data was in many of the data sets not so good, but for some of the time lags in the data of ALOS 2, Sentinel-1 could provide a supplementary insight into the deformation of the landslide. Then we had a presentation by Claudio De Luca, not on ALOS data, but on SARCOM data, which was very nice to see because it was a very nice, different examples of using these data. And like I myself haven't seen so many studies using SARCOM data in that manner yet. And we could see a very nice C and L-band comparison, also together then with X-band data for metallic structures in urban areas. Then he gave some advices for using SARCOM data in general. So if you have any questions, I think it's good to contact that group. And we also discussed ionospheric disturbances. Then in the roundtable, we tried to get some feedback for ESA to support this collaboration because it was just renewed for another year, and it will hopefully also be renewed for ALOS 4 in the future. So we tried to get the best out of the session. So again, acquisitions over Antarctica and Greenland are necessary. There are only very few so far. Then there was a point to acquire C and L-band shortly in time to study different effects in C-band, which you could potentially see in L-band and the other way around, so considering atmospheric effects and ionosphere. Then dense temporal acquisitions and long time series are needed for many different applications like the soil moisture or the deformation monitoring. And there's a collaboration need for validation and ground truthing, and I can confirm the agencies started collaborating in this manner already because we will all have different missions up there in the very near future. And then just as a last point, this phase closure, it was like, I think, a big part of the conference, so I wanted to emphasize it here that that was a new application of SAR interferometry. And that's all. Thank you.
Fantastic, thank you so much. Great session summaries there and lots of detail. So now I think we're going back to the SAR geodesy and the atmosphere and ionosphere session chair. So Jacob, we can work collaboratively to get those presentations out of order back on the screen. Here's your little clicker.
Thank you.
Slides. Thank you very much. Take it away.
Thank you, and sorry for the delay. I will present the summary of two sessions, the mine from with Amelung, and okay, my name is Nick, and also the other session on behalf of Lanari and Einader. So in my session, was focused on ionosphere and correction of atmospheric artifacts, so to speak. And there were 5 presentations, 4 presentations, 3 related to the correction of ionospheric and tropospheric artifacts, and 1 on SAR meteorology. More details are in the slides. So the first paper was from DLR, from Felipe, who presented an autofocus algorithm that has been developed for the polarimetric calibration and correction of ionospheric artifacts on P-band products. It was, it was a study related to the new mission biomass. Then there was a work presented by a colleague at GPL on the methodology to mitigate atmospheric artifacts in both space and airborne L-band interferometric data. And it was an application also of a technique, independent component analysis. Then my presentation that was focused on SAR meteorology, and so a new, I'd say, application of SAR data, so to speak. And the last presentation was on a new model to correct both the components of turbulent and let's say stratified artifacts of the atmosphere, and was applied to the correction of a time series of INSAR data that are referring to an earthquake in China. And there were also a few posters. These are the posters I managed to associate to my session. The first two are clearly related to the ionosphere, and the last two are related to the correction of tropospheric artifacts. There was also an overlap with the next session, this one, that had Lanari and Aneder as a chairman. There were 5 presentations, more related to the use of the new ESA products, ETAD, and then it was also it was discussed also about the evolution of the current version of this product. There is need. It was emphasized also the need to work to work more on the quantification of the potential of atmospheric INSAR phase reduction. That the work that should be done in the future by the different teams, and also the need to use also the code tech maps to correct also the ionospheric artifacts. And okay, this is just a few posters that Michael managed to associate to this session. So there was also a discussion, a roundtable discussion after the end of the 2 sessions, and these are a few points that have been discussed. One point was the need to have external sensors, like for the case of MSAT and Maris, to measure and to also to validate the algorithm to estimate the water vapor. There was also a proposal to have identify supersites or test areas where, together with the site data, there could be also other in situ data or auxiliary data sets that can be used for validation, development of new algorithms. There was also a discussion about the ETAD product and also on the grid that should be used for LC products. And about this, a decision recommendation has been postponed. Also, there was also mention to similar work that has been is done now currently at JPL. And the recommendations. This is just a few recommendations that we managed to collect. One was to maybe the most important recommendation was about ETAD products and the latency that should be short, so to speak. There was also, after the discussion during the session, there was a request, so to speak, from colleagues of industry that are using this data to provide services. For them, it could be useful to have this data within, let's say, 48 hours from the acquisition of the SAR image. So this was one of the recommendations that has been done. Another was also to define and use methods to quantify the reduction, the mitigation of atmospheric signal. Also, there was a recommendation about the validity of algorithm, especially for ionosphere, also to be used in the perspective use with raw cell data. And there was also another recommendation for ESA to publish algorithms that have been used for the correction, and then all the corrections should be also reversible, in the meaning that the user could also be, at least that was my understanding, that users could also, say, avoid to use them, and also longer interferometric across-track baselines could be also useful for certain applications, and maybe. I can also add another recommendation that was not discussed at the end of this session, that was discussed, if I remember correctly, yesterday during one session about emission, referred to one question, one comment by Ramon that could be also useful for SAR meteorology, which is also to reduce the, I'd say, the revisiting time, the temporal baseline, in order to have some data set that could be useful for this, so to speak, new kind of application. Okay, that's all on my side. Thank you.
Fantastic, thank you very much. And I think if any additional recommendations come through, then add them to the slides and send an updated version to ESA so it can be formally captured in the results that will go online afterwards. My microphone, it's working now. So we go, there we go. Fortunately, I have a loud voice. Do we have data products and services in the room? We don't, so it's me. So.
Okay. Lisa, now ice and snow.
Fantastic, thanks very much. So the Ice and Snow session at Fringe this year was a blockbuster, as it always is. We had 2 sessions jam-packed with exciting presentations that were showing results from using Sentinel-1 and other SAR sensors to measure ice velocity, grounding line locations, looking at permafrost, snow, and all of that good stuff. The session chairs are named here, and we had a really lengthy set of seed questions that we wanted to talk to the community about. So if I just skip forward, I'll go through in turn. I apologise for the smallness of the text on the screen here, but we wanted to make sure that all of these recommendations made its way back to ESA. And so first up was, what are the most important science questions that should be addressed using SAR data in the polar mountain regions? We said that we were really excited by this dense repeat sampling of various different parameters such as ice speed, and that's been a real game changer over the last 5 years. And so we want to be maximising our use of that new information. However, we also pointed out that the sampling could be even denser, and that would enable us to study new processes and information that we can't have with the existing set of ESA missions. And so we think that there's a good opportunity to work with either commercial or other space agency data sets to augment the ESA acquisitions. And so any kind of community access to those third-party missions would be really well received. There was an extremely lengthy discussion on the gaps, scientific and technological, in terms of monitoring the ice sheets and glaciers and snow. We note that the one-day repeat period that we had through a few dedicated phases on the ERS mission it has been missing since then, back to the early 1990s. And this is still a big gap because it means that producing grounding line products over certain regions that are particularly fast flowing is still challenging for us. We note that that surface water equivalent products would be useful, and maybe the existing products aren't frequent enough or not reliable enough for the water sector perspective. There's lots of good information on snow thickness and snow structure that can be produced from SAR data sets, in particular when we've got multiple frequencies. And so we think that there's an opportunity in the mid-latitude and alpine areas to investigate this in more detail. Time series of digital elevation models produced from INSAR are missing. It was fantastic when we had these from the TandemX mission, but there is nothing in the future planned, and this is a gap. There are uncertainties in a range of our parameters that we feel could be better quantified. So, for example, uncertainties in surface elevation, change, and also velocity. And we need to have a coordinated campaign to kind of get a better handle on our uncertainties and error estimates for all of these parameters. That will need both using existing satellite data sets, acquiring new images that are coincident with each other from a range of missions, but also having dedicated CalVal campaigns to address this in more detail. We note that biomass is on a 3-day baseline or a 9-month baseline when that will get launched, and the acquisitions for Antarctica are anticipated to be good, but there needs to be more discussion about how we will actually use that as a community. And there's a lot of discussion as well around permafrost, about having short acquisition temporal baselines, investigating thaw slumps, and having higher frequency single pass or multistatic mission data required for it. Crucially, though, we note we definitely want 6-day repeat acquisitions back from Sentinel-1 as soon as Sentinel-1C is launched. The community made full use of this data set when it was being acquired between Sentinel-1A and B. We're bereft without it, and so we can't wait for it to return. So although this may seem basic, it's probably the most important recommendation from our community, I think. And definitely don't decommission 1A until D is launched as well. So next we looked at how we could coordinate and optimize SAR acquisitions over ice sheets and glaciers. This is something we've done really well in the past with organizations like the Polar Space Task Group, where multiple space agencies committed to come and work together. But that hasn't been functioning quite as frequently as it was at one phase, and so we need to reinvigorate that going forward for all of the excellent SAR missions we've got. We have options to fly Roselle and Sentinel-1 in formation, and so we want to consider how they could be in sync with each other, and having these multiple frequency options is going to be game-changing for us. We want to be able to map extreme events and small events, and again, this high temporal sampling will be really important in order for capturing that. And having EW mode SLCs would also be useful. We saw some great results in the session on that, but maybe we could expand on it. In the interest of time, I'm just moving on. There was a lot of discussion about calibration validation campaigns. As I've already mentioned, error characterization is really important. For example, for products like ice velocity, it's not the total magnitude of velocity that we're necessarily interested in characterizing the noise on. It's on the velocity change signal, which is an order of magnitude more difficult to deal with, and that shouldn't be forgotten. For permafrost, we can use INSAR to infer subsurface processes, and we're excited about doing that with Roselle. And we need to have this coordinated calibration validation campaigns that cover the range of different scenarios and range of different frequencies for the missions that we've got available to us. New SAR data products are available and on the horizon using AI and ML, for example, mapping fractures on the ice sheets is a really exciting example, but there are more. In terms of which SAR acquisition strategies are available and SAR products are needed for monitoring of climate-induced changes in permafrost regions. We know that the products exist, but they're not used enough, and L-band will be even more useful for this, so we think that Roselle will be a game changer there. So just to summarize and wrap up, we've got a number of key recommendations coming out of the community. Top of the list is resuming 6-day repeat acquisitions from Sentinel-1 as soon as possible for Antarctica and Greenland. Validation campaigns, we're in the perfect time to start coordinating between space agencies so that multi-frequency SAR acquisitions can be better understood, which will enable us to develop new products and to better characterize the error and accuracy of our existing data sets. Soil water equivalent retrievals within SAR, the methods are physically understood, however we need reference points, so therefore further development is needed. And volume changes from INSAR can be calculated, but we need continuity for missions like Tandem X and also preparation for upcoming missions like Harmony. And we're optimistic about flying Roselle and Sentinel-1 close formation to enable us to do some of this work. So thank you very much.
Thank you, Anna. I think the next one is INSAR methods, please.
Morning, everyone. So in our session, we have 4 papers. So from around the world, so the paper 1 is from Dell, the paper 2 is from Grenoble, the paper 3 from Rome, and the paper 4 from Pasadena. So it's quite diversity, it's interesting. So, and it's a really interesting session. So the paper first, we talk they talk about how to handle with the discontinuity in the time series data. And the paper 2 is dealing how to better decompose the unreliable bit cell from the non-closure phase effect. And then from that paper, we learned that non-closure phase is not really the bias that is signal inside. And that is one of the things we learned from that workshop, and that's a good thing. And the paper 3 is dealing with a little bit about the classic problem about how to identify the persistent scatter to better extract the data in time series. And the paper 4 is talking about how to better exploit the fail linking application to dealing with the data in the area of the big data INSAR nowadays. So we have a lot of discussion, and then we also provide some questions, and we got some outputs from the discussion. So there's 2 main outputs. So the first is the perspective of machine learning, like deep learning. So basically, the algorithm, the signal processing is quite well known, well documented. So there is a little bit, maybe a little bit room for deep learning to improve something. However, that's within that deep learning can help us to speak up almost everything, maybe more efficiently. So there is a lot of potential to exploit deep learning for a variety of applications like file unwrapping, like file linking, like try to find an outline in time series, and also assist in as a kind of post processing in a certain application like alarm related information. So the output number 2 is we got a lot of mention about a lot of discussion about the bias, and we would try to correct it. It's not really about the signal inside. So how do we better understand the signal related to the non-closure phase? So there are two perspectives to consider that problem. So basically that in terms of the physical aspect that is the signal. So there is a lot of demonstration how to retrieve that information for some monster application. And for the other application, we had to treat it in a statistical approach. So basically, with the deformation application, we don't want that non-closure phase. So we try to eliminate this during the processing. So usually we can exploit some certain approach like statistical approach like file linking. And the people comment that the open source file linking such as Tombosa is really good for the community. So there are 4 recommendations for ESA. So the first, we had to know where we are, what we want to do. So for deformation applications, so working on statistical phase linking, or if we exploit the point position in single look connect, it's okay. There is no problem with the non-closure phase. So there's a lot of commands to transform some open source available, for example, Tomosa for file linking and Stamp for the BSI. Both of back case is open source, but the problem is they are available in MATLAB. So it's better to transform it to Python, so that the community can exploit it a lot, because there is a lot of problem with MATLAB, Python for everyone. So there is a need to support to make such tools available in Python. So the second is to extract the physics signal inside the non-closure phase. So there is a need to study a comprehensive study to understand what exactly mechanic inside many scenarios, like forest scenario, like vegetation, like agriculture, and like the bare soil. So the number 3 is comments from Ramon Hansen. That's for inside processing, especially when we do correlation with the top. It could be nice if we have a reside orbit, just decrease the time to deliver the reside orbit to something like 24 hours. It would be great for the inside community, for easier to do top correlation processing. And then the final one is the systematically product for atmospheric correction will be essential to reduce a certain artifact during the inside processing. Okay, thank you.
Fantastic. Do we have the chair for the ground motion service session? A repeat performance. Welcome back to the stage.
It's again me. I would just read because Michele promised me free beer next time I will visit Barcelona. So.
Great negotiating.
Okay, I try to summarize. So if something is wrong, please correct me because so the session concerned the exploitation of Sentinel-1 data for wide area, such as the Copernicus European ground motion surveys, and there were 5 presentations, which are not been listed here. The roundtable discussion was starting with if the current version implementation of GMS surveys is meeting its objectives. And there was a general consensus saying that, okay, EGMS is meeting set goals, and so it's doing the work that it was expected to do. Okay, I'm trying to read it. there was also some open issue about some phenomena that had not been correctly mapped. I remember that there was a presentation about some corrections, for instance, in the area of Naples that has been done by the group of CNR. It was discussed also whether the loss of Sentinel-1B will affect the service, and my understanding was that the 12-day baseline would be still useful. It was discussed how well EGMS can combine Earth observation and non-Earth observation geospatial services, and how to integrate these services. Some participants indicated also the need for API to access this data from EGMS. And it was discussed also that user communities need information about results that have been that are provided by EGMS. And I remember that Lanari pointed out also the need to distinguish the area where the result is coming basically from GNSS and the others where INSAR is contributing somehow. The performance of EGMS was discussed, and different aspects were mentioned that should be considered for the future. It would be useful to visualize the basic products within the Explorer used by GMS. Will be also important to have access to some other data, for instance, soil moisture, and this was a comment that was done by some colleague at Geosphere. Users should also be able to download a time series over a given area of interest. Also, the mitigation of atmospheric artifacts should be improved. And another point that was raised was the accuracy of geocoding and of the products, and also the link between the GeoSAR exploitation platform and the Copernicus EGMS should be improved. And at the midterm, there was the need to use also the amplitude besides the interferometric phase. This was a comment that, if I remember correctly, was done by by a colleague in the industry, and also the need to use also the product in the L band, and to enhance also the information along the north-south direction. There were made also some recommendation. Tools should be made available, and the experiment should be conducted in order to enable and promote the combined access visualization of soil moisture. This is the comment I mentioned before from Geosphere. And methods should also be developed and tested to enhance the result of phase unwrapping using both C-band and L-band results. I think that's all. Thank you.
Fantastic, thank you very much. So next up, we've got the advances in INSAR theory. Do we have the chair for that session? Come on down.
So I was the chair here in this session where there were two sessions, Tuesday, Wednesday and Thursday. And it was Ramon Hansen, Bart Larsen, Howard Thepker, and myself. Here you have just a bullet list of the papers. As you see, there was 4 contributions on these non-closure phases for moisture retrieval. So the point is this topic is now gaining much more interest. And so there are, of course, 2 philosophies. One is if we want to see the formation, we want to remove the bias. So this was these 2 first contributions. But of course, we know also in this non-closure phase there is information. And the other 2 contributions were about how to exploit or to understand what's inside. Then we had also 5 additional contributions, 5 different topics. One of them also mentioned before by me. It's on the improvement of the phase linking algorithm, also related to somehow to this non-closure phase. Also on 3D phase unwrapping or twice 2D phase unwrapping of time series. Also on the contribution on efficient time series processing of large stacks. This was given by Howard Thepker. And also Lopez Martinez was proposing an interesting, a new interpretation of the temporal coherence, temporal decorrelation. And then finally was also an effort, an interesting presentation also on the error propagation. For when we deliver a time series, we want also to provide the confidence of the measurements. I can only recommend that you take a look at the presentations if you didn't have the chance. So if I'm not wrong, they are available at the YouTube channel for how long? Forever.
Forever, I think.
Forever. So, but don't wait too long, but then in some years this will be outdated. So yeah. So far about the summary, and then we were providing some seed questions, and then here also the community was very active, providing many recommendations. So the first slide, it's on the phase closures. And you see the title summarizes it pretty well. So we need to better understand all about these phase closures. So the first was to maybe make an effort to establish supersites related to this research. And mainly, so many aspects were mentioned. For example, the availability of ground truth, possibility to have observations, different sensors, different wavelengths. And also someone was mentioning the possibility to combine also GNSS reflectivity. There is also some potential to retrieve soil moisture there. It's not here, but now, I think it was also mentioned the potential to cooperate with other agencies, like, for example, CONAE. With SAOCOM, they also have test sites already to make soil moisture cross-checks. Then also related to phase closure, so we need to distinguish the different driving mechanisms behind phase closure signal. So we know we have soil moisture, we have also vegetation on top. In addition, we have deformation. So we need to better understand what's going on when we have the mixture of all these contributions. So it was also suggested to ESA could support on organizing a scientific science community working on phase closure signal. So, working group could be an idea. And it looks like, so next conferences will probably have a dedicated session on non-closure phases. So it could be next FRINGE, could already be next IGAS. So the next topic was also addressed, the L1-C1 combination. And well, some of these topics have been already commented in all of the summaries we have seen so far. For example, Roselle, which should be the orbit of Roselle with respect to our Sentinel next generation. So we need to ensure the same beam geometry, repeat pass, and resolution. I know for ESA it's maybe clear, but it's obvious that these questions were coming for the community, so not for all the communities. Maybe it's clear, that's why we were leaving this bullet point here. ESA can then address this question. Okay, the second bullet point was already mentioned, so which is maybe which separation should we have between Roselle and Sentinel-1 or Sentinel-1 next generation. So these are things that the community needs maybe to further think about. And also this was already mentioned also before in other sessions. So we want to also extend the cooperation with other agencies. And then one of them is this, especially SAOCOM, in order to facilitate conducting experiments related to different applications, and of course making data available. And I have two topics that were also discussed in the past, also in the previous FRINGE, but we decided to capture them again. So the first one was already mentioned. So the community will be very happy if we could have the precise orbits much faster, not to have to wait 20 days. And also, investigated this possibility to have the precise orbit information earlier. So less than 24 hours, but considered trade-offs. So I don't know what exactly here was considered. Anyway, but the two are linked. So we want to have precise orbits as soon as possible. Probably we can extend this and provide a new slide. And concerning baselines, this was also discussed in the past. We are aware that there are different communities asking for small baselines, some others for large baselines. This is another suggestion, maybe during the commissioning phases of Sentinel-1C and D, to try to maybe have 3-4 repeat pass cycles with larger orbital tube. So, but this would only be during the calval phase of these satellites. Should not be done routinely during the phase, the commissioning, not outside of the commissioning phase, after the commissioning phase. So it should not be too much of a drawback, hopefully. So that's it then. Thank you.
Fantastic, thank you very much. And I think that orbit, having the precise orbits available quicker is something that we can all get behind for sure. So next up, we've got displacements and deformations, moving into the tectonics and volcanoes session. Summaries.
Thank you. So we had 2 sessions with 4 session chairs. So thank you to the other chairs who weren't able to be here, and of course Mario, who is. We had quite a diverse range of talks, so we haven't tried to put together a summary of all the different information we had. We had a lot of different applications. We had a huge range of different scales. So we had some presentations looking at continent-wide data, country scale analysis, things like taking EGMS data at the continent scale, but scaling it down and looking at it, using that wide consistency, but looking at it at individual building scales, down through sort of site-wide, smaller sites, building applications, corner reflector use for looking at small items of infrastructure, right the way down to SAR antennas mounted on a car. So we had from continents down to cars in our session. We also have quite a range of different recommendations. They're quite wordy, so I'm not going to sit here and read them all out, but just trying to summarize them. Again, picking up on some of the things that came out in the previous session summaries, a constellation approach, trying to optimize the revisit times, getting that really regular repeat, harnessing the expertise from the L-band scientific community, so sharing expertise between missions, coordinating, and trying to make the data accessible to the scientific community as well as we possibly can. Again, with the variety of different scales of applications, in our session we had a discussion on how those different communities could be accommodated, and one mechanism that was highlighted for trying to accommodate the really small spatial scale things down at sort of individual buildings, individual structures level was the complementarity between the Sentinels and the Copernicus missions. But on the flip side of that, the Copernicus missions have a really fantastic capability to give us really wide-scale consistency, both spatial and temporal. And so if we can try to coordinate and accommodate the needs of both the sort of wide scale and the small scale within our future missions, that would be really beneficial. There is a great complementarity between the satellite systems that we use and all the various kinds of ground-based data and ancillary data, whether that's ground-based or satellites, things like corner reflectors, which provide a really great basis for validation. That one, I think we've probably covered quite a few of the points already in previous ones, so I won't dwell on it. There was a discussion on whether or not ESA should be investing in research on post-processing to extract information and warnings. And there were 2 viewpoints on that. Some of the discussion said the scientific priority should be providing good data without taking responsibility for sort of deriving the products for the end users. There were other people who advocated multidisciplinary cooperation and working alongside directly with the end users. So a lively discussion on that one. But there is definitely interest in investing in post-processing tools and methods and trying to generate user-friendly outputs from these things. And as expected, yes, funding for all of these things would be appreciated by lots of people, I'm sure. And one piece which we didn't really have much time at the end of our discussion to come onto, but which we'd flagged would be a good thing to discuss in future, was the role of the platforms hosting the INSAR processing services. So what is the future roadmap for things like the Geohazards Exploitation Platform and the Earth Console? And I think the session flagged that it would be good to have a discussion on what that looks like and how we perhaps move towards a more unified approach than we currently do.
Fantastic, thanks very much. We'll wait to see whether Marcus has a big funding announcement in his closing remarks at the end of this session. So can I welcome up the Earthquakes and Tectonics session chair? Put your little clicker there.
All right, thank you. Hi, I'm Katerina Timofeeva from JPL, and I had the honor of chairing one of these 3 earthquake and tectonic sessions with these wonderful people who are listed on the slide. So basically, we saw many posters and talks on earthquakes and tectonics, and they had to do with a variety of topics, applying Sentinel-1 data to look at fault properties in various regimes, subduction zones, continental boundaries. Seismic hazard assessment was addressed in various ways, particularly using INSAR strain measurements, which is a new topic that many of us are exploring. Addressing challenges in applying INSAR to research in tectonics, challenges that have to do with noise, resolution, temporal sampling, and biases inherent in different methods that are used for this research. Large-scale processing of INSAR data, observing earthquakes in various ways. There were talks on automated detection of earthquakes and event response using damage proxy maps and other methods. So this is just covering some of the topics. There was a lot that we discussed, but the main takeaway from all of it was that really the vast Sentinel-1 archive provided by ESA has truly revolutionized the way that we do research and the way that we are able to study earthquakes and tectonics using INSAR. We had a very lively discussion at the end of our 3 sessions, and we came up with quite a few recommendations. I will not go through all of this. There are quite a few notes about what we discussed, but I will just highlight the questions that we asked and the recommendations that came out of these discussions. So the first one had to do with a topic that came up many times during many of the sessions at this particular meeting that has to do with the effects of soil moisture and perhaps other things that drive a loop non-closure in multi-looked INSAR time series. There are ways of looking at them as signals or as noise, but our recommendation on that topic particularly is that we believe that this topic deserves a designated workshop that should be hosted, and so that we can all get together and have further discussion on it. So our second question was, what scientific advances do you envision will drive this community in the future? And the recommendations that came out of that is that for future research to be successful, it would be great to see ESA launch Sentinel-1C as soon as possible. And also, it is important to have long continuous time series as much as possible. So it would be good if archive data were not deleted. And it would also be very useful for all of us that if the format of the archive data stayed the same through time, because it makes it difficult for us to work with if it changes. Third question was, what challenges do we face in earthquakes and tectonics research today and implementing existing SAR data sets, and what changes do we need from the SAR data mission or future missions or current missions to help push the science forward? And we have quite a few recommendations here, I believe. We do face many challenges depending on the data sets that we use, depending on the location of our studies, and depending on the methods that we apply. We recommend that that we look further into comparison to address the differences in INSAR processing and interpretation methods, to address the specific challenges in estimating INSAR deformation time series and velocities. We also recommend for Sentinel-1A and future generations, there was a concern that the baselines are getting longer, and even though it is difficult to keep them within short baselines because of the trade-off with mission duration, we would recommend that the baselines are kept within the original 300-meter tube. And a recommendation for Sentinel-1 next generation and Roselle to have bigger overlaps for the bursts to be able to constrain north-south deformation better than what we do now. 4 is a related question: what measurements or observations are missing from current and perhaps even planned missions? Lots of recommendations here. One thing that I think the community really agreed on was that we should not immediately park Sentinel-1A. We should not get rid of it as soon as Sentinel-1C is launched. It would be really nice to just have all of them up there. I know this is all things we're wishing for. Let's see if they come true. A recommendation for Harmony is to make level 3 products available, because it is going to be a complicated data set for people to put together. So make level 3 products available quickly and easily, if possible. Another recommendation relating to the Sentinels was that if in the case that Sentinel-1A fails prior to the launch of 1C, it would be good to negotiate a preemptive deal with RadarSat to fill in the gaps if that happens, so that we don't have a gap in coverage. Also, there was a lot of discussion regarding what the commercial SAR constellation can provide, and I think there are several points in these notes about that. But one is to negotiate with the commercial SAR constellation, if possible, to provide some kind of regular minimum coverage, because their data could really be useful for event response, but it isn't useful if there are no pre-earthquake interferograms or pre-event interferograms, whether with earthquakes or volcanoes or other events. So if that is possible, that would be a very useful thing to have. And a big recommendation was to form a formal international SAR tectonics advocacy group for negotiations with space agencies and other agencies to support tectonic science needs. Another final recommendation on this topic regarding observations is to, whenever possible, pursue boring acquisition strategies as long as they are continuous. Continuity is very important. So number 5 had to do with disaster response and how it is addressed by SAR data and what needs it has. And the recommendation here was to pursue more coordination with the commercial sector, again, and to negotiate access to data that perhaps we don't have at this moment. Number 6 was to do with ETAD's current plan for data provision. And of course, the recommendation is to, the more data that they can provide, the better. That would be wonderful. Keep the format of the data sets consistent and simple when possible. And provide uncorrected raw data along with optional correction layers. An additional recommendation was perhaps to add a layer that is a land cover map to the INSAR data sets. Perhaps that would be useful for some of these more soil moisture or more kind of different applications. Number 7 is what other recommendations. So this is just a catch-all topic, just anything that we haven't discussed before. The first recommendation was to make sure to provide open access to data, to SAR data with open and transparent licensing. Someone recommended that we should ask the military if it was possible to release their old data sets. We can see how that goes. We can explore the possibilities of adding other instruments to SAR missions. There were people who considered that it could be useful to have a MARIS-like instrument for water vapor estimation, or we could brainstorm other things that we could add to SAR missions if we want. The other recommendation was to explore improving the revisit time for disaster response. How far could we push our disaster response and the science associated with it? If we had, for example, a 1-hour revisit, something like this could be achieved with maybe something like a geosynchronous satellite or some other mission design. We also would like to study the best approach to launch Sentinel-1C and D if 1A stays in orbit, provided we don't park it. So do we launch them, where in the orbit should we put them? Perhaps one of them should be a day away from Sentinel-1A. Perhaps they should all be evenly spaced. That's something that we could explore as a community based on our needs. And finally, explore the scientific utility of an architecture that gets very short visit time once in a while, 1 day or shorter, similar to what the commercial constellation does, but providing more regular and, I want to say, reliable background coverage. So that's all for us. I tried to go through it quickly because it was long. Thank you. I want to make one recommendation, please, if possible. It would be good if we could have the Turkey earthquake discussion now, because it's a little bit related to us, so it makes sense.
Yeah,
That's
we've
okay.
we've got coming up. We've got volcanoes, missions, and Turkey earthquake. Who's doing the Turkey earthquake? Do you want to come and do the Turkey earthquake now? Does anyone have any objections to us shifting things? We've already shifted it slightly. Thank you so much.
Thank you so much.
There's some great recommendations in there. I didn't like the mention of the potential death of Sentinel-1A, but hopefully we won't have to mention it again, and it will never happen. Take it away.
Okay, thank you. So it's so much related that I thought it would be better to come up now. We had a special session on the Turkey earthquake in February this year. So this has been a great tragedy. So we don't forget this when we get excited with our science. We need to balance this a bit. We just have a very short summary slide. It was a late-breaking session, so people had to adapt very fast. And the interesting thing is that we can do that now. And we have fantastic coverage of images for this earthquake relatively fast. I'm not sure how many of you followed this in the media and social media. I think there has been a very quick uptake of scientific results that can explain what happened, why it happened, and so on. So for us, this is kind of a milestone in this community, and this is very interesting. I just make a personal experience. I was super proud of our community that we made it just a few days after the earthquake into the main German news channel on prime time with the pixel offset maps of the 2 ruptures. Yeah, so you have news media saying, okay, here this is the rupture. We have an offset of this and that, and this happened and why it happened. So this is great because we made it there. In this regard, we discussed a bit the role. We don't come up with an answer if we as a community, if we should move a bit closer with disaster response and management. I think we feel all very comfortable with, doing science and having ideas how one could respond better. The question is if we really engage a bit more. This is an open question. I think maybe we can discuss this at a later point a bit deeper. I mean, we provide really good methods, I think, in scientific way that can be adapted later. What has been scientifically very interesting was that we have combining Sentinel but also ALOS data and with INSAR and also with pixel offset measurements, 3D imaging of the earthquake, fault zone and also the near fault zone. What happened? We have a damage zone that could be imaged, and this is very interesting because since some time we have theories how fault zones act, and we can now add data to this. This is quite new and exciting. And we have also many observations of off-fault damages, so very small signals that we have also seen for other earthquakes. It's also very exciting because we can see that the crust behaves not just at the fault, but by the way, with small signals, and for this we need high coherence imagery, and we need revisit times that are short, and we need small baselines that the coherence stays high. So this we add this to other communities' recommendations. I think that's it, right? Is there another slide? I think it's just one, right? Yes. So thank you. That's it. There's another slide. Oh. No, there's some important things. I'm sorry. The north component. I think we had this also before. Also, we think the north component, we try to get this, but it's relatively complex. So if we could be better, harmony is great. Concerning the earthquake, we are a little bit puzzled that there's relatively little after slip and post seismic. This is something scientifically interesting. Maybe we get more of this in the future and hear more about this. Yes, I stop here. Thank you very much.
Fantastic, thank you very much, and that did match on really well there. So next up, we've got volcanoes.
Okay, so you will see that in the volcano community, of course, we have a lot of recommendation and conclusion that's already been said from the tectonic or from the ice community. We are facing, of course, challenges. Here I just put, I think, just the 4 challenges that we saw over in the presentation and in the poster. So first is to discriminate between mixed signal. So it could be between the atmospheric noise and the deformation signal we want to retrieve. It also can be mixed signal between 2 different sources. So if you have a shallow and a deep reservoir and you want to try to detect the 2 signals. Of course, we use INSAR to understand the coupling processes, such as the interaction between volcanoes or the effect of external processes. Tracking also with accuracy the topographic changes related to eruptive activity. And also, we need to prepare for the next mission, NISA was L Harmony, and ensure that our methodology or the algorithm that we are producing can be reproducible and transferable to other missions. Okay, so here's just a quick summary of the presentation and the poster. So we had a lot of course, presentation and poster about Sentinel-1 time series, as I said before, for the tectonic community. Sentinel-1 very change the way we have to monitor and survey volcanoes. So we can do now also global studies. There was a lot of presentation about individual volcanoes also, Galapagos, Mauna Loa, Askia, Tulumuye, Chiles, when we have now a long time series over 5-6 years with a very short revisit time. And this is very important for our community, is the short time revisit of Sentinel-1, because we now better constrain the temporal evolution of magmatic system, which was not possible with previous sensor. Okay, so with this temporal evolution, we see that, of course, it's nonlinear processes, and it can give us insight about the rheology around magma reservoir and also a better understanding of the coupling processes. So here, just to repeat, here there was a large amount of Sentinel-1 data that are collected now for almost 10 years, and then we are moving from individual study to also global study, and many talk emphasize the importance of developing artificial intelligence algorithm, machine learning, and also blind separation methods for the detection of ground deformation signal. There were a couple of talks also using the time series and the Sentinel velocity maps to derive, of course, the magmatic source, their depth, and the kind of process that are involved. But still it's difficult to discriminate between magmatic and hydrothermal processes. And of course, we always need to gather additional information to try to understand better and discriminate between the different signals. And in addition to ground deformation studies, I mean, our community is also one important data set that we need is high resolution topography. So high resolution topography, why? Because first, it's useful for the processing of the INSAR, so you can update UDM and do a better job, but also for hazard management and to detect topographic changes. I mean, volcanoes are very dynamic, and there is topographic change due to dome and lava flows, and this is something we really need to tackle. So there were, of course, there is the ESA Harmony that's going to answer this question, and also there was an initiative from NASA that Paul Lundgren told us. It was like the surface topography and vegetation. So we try to prepare also to this next mission and see how will be the effect of spatial resolution and the damage error from the retrieval of topographic changes. So we have several seed questions, so we try to discuss around this question. So how can the future radar mission be optimized for volcanoes? So here, it was already said, but for example, for the Rose L, we really need burst overlap if you want to return north-south motion, and also the Tuluk scatters is something important for us. And the continuity in time series, so it was already said for the tectonic case. But if we have Sentinel-1C and D, and Sentinel-1A is still working, I mean, it will be, of course, better for us because we have continuity in the time series, short revisit time, which is really important. The complementarity of L-band, of course, we are dealing with a lot of vegetation on tropical volcanoes, and sometimes it's kind of tricky or difficult with the C-band. So it will be also a good step for having additional information, and try to ensure that there is no too much gaps in the Sentinel program in the future to keep this high temporal resolution. The complementarity of non-deformation observation. So here we go back to the topographic changes, and it was mentioned by Anna already. It's like we have harmony. We know that the topographic change is going to be at the beginning and the end of the mission. So what we are doing in between. So we need to think about other data set or how we're going to handle to keep kind of a time series of topographic changes on volcanoes. So we will, of course, rely on harmony for some time, but we have also to think beyond that. For the harmony, we think, yeah, it's important to have ascending, descending track, and also to have a global coverage. So we have the experience with TandemX that was a very amazing mission to retrieve topographic changes. But the coverage and the temporal resolution we get from one volcano to the other is very different, and you only have a few volcanoes that have this high temporal resolution in the archive. So how we can better that for the future mission. It was mentioned already, pathway for commercial operators to contribute. So how is it possible that ESA can help us to get access to this kind of commercial data sets? So it's an open question. And keep also background missions, so the same thing. Background mission with continuity is kind of needed for our application. Then the benchmarking, I think it's important. It was already mentioned that how can we provide test sites, so it could be on the framework of super site in different environment setting. For volcanoes, we are dealing with vegetation, so low coherence and topographic changes. So that will be a good thing to test algorithm development for the unwrapping, time series analysis, anomaly detection, and so on. So can ESA provide like a framework or can help us to build this kind of benchmark studies? And then finally, what data or method are most important for volcano monitoring and therefore for disaster risk reduction. So we know that there is a lot of different algorithms that were developed, machine learning, deep learning, to try to detect globally. But of course, it will always depend on the quality and the continuity of the data. So we need to ensure that we have at least a global coverage and as much as possible all the active volcano covered by the future mission. So it's always, of course, different community. We have different priorities. So how can we handle that? And I think that's it for me.
Fantastic, thank you very much. Lots of useful recommendations there. So next up, we've got the missions session summary. We're on the Homeward Straight team. Only a few more session summaries to go, and then it will be lunchtime, and we can all go on to our weekends. Take it away.
Thanks. So for missions, we have two sessions. Missions 1 was chaired by Björn Romen and Irena Heinzek. Second part was chaired by Marco Laval and myself. So in missions 1, actually it was focusing on the 3D deformation problem, where we could see different approaches. So the first one was related to new missions using co-flyers or companion satellites as Harmony, or also the approach that JPL is taking. Second approach was to use satellites which are not using sun-synchronous orbits, but mid-inclination orbits to be more sensitive for lower latitudes. And the third approach was the use of two-looks or squint angle diversity, like, for example, for Harmony or for Rosel. Sorry, this was for Rosel, where it was proposed to maintain, let's say, the timeline that was computed at the beginning, but doing some technique on the radar where you can obtain two looks at the expense of some noise equivalent sigma 0 loss. So there was a small discussion if we can get that, let's say, at a lower cost. There was also one presentation related to along track interferometry, which was related to mitigate ambiguities which are coherent. In the missions 2, we had 2 or 3 presentations which were showing recent INSAR developments with commercial SAR constellation of small satellites. Also, there was a presentation on Gaofen 3, which is a Chinese mission where the presenter was showing time series results, which look very reliable. We had also a presentation on Ka band to measure the topography with a very high accuracy and with a focus on the cryosphere. And we had also one presentation which was assessing the quality of ISI and SAOCOM in the frame of the EDA Plus project of ESA. So I move to the recommendations. So the first recommendation was related to let's say, to increase the cooperation between ESA and Chinese authorities, especially, so there have been a launch of a geosynchronous satellite, Lutan 4, and the community was like very interested to obtain a higher revisit. So Ramon Hansen was mentioning that there has been a meeting, or there are some meetings in the frame of the Dragon project, so the community would like to have an exchange of data. Second recommendation is that ESA should consider the use of commercial SAR constellations for geophysical processes that require very fast revisits, so below 1 day, to accommodate emergencies or disaster response. In this way, we can improve the longer revisit time of Sentinel-1 or so. Next recommendation, I think, is related to the previous one. So interacting with the private sector to acquire additional data with consistent geometry with already available for Sentinel-1, as far as, of course, the orbital constraints allow for that. I think this is more related to obtaining a reference image if there is a disaster. So another recommendation is, so there were some presentations mentioning, which are foreseen using mid-inclination orbits to get higher sensitivity to the north-south. So another recommendation related to mid-inclination is that there is a variation of the local acquisition time, so maybe more work is needed to investigate that. So we will not have only seasonal effects, but maybe also sub-daily effects related to changes of temperature. So there was also a recommendation of performing multi-static experiments, because until now, all the campaigns that are available have been only considering biostatic configurations. So missions using co-flyer satellites seem to be very exciting because they can unlock new science aspects that are not possible with current missions. So the combination of Sentinel-1, Next Generation, and Rosel can be very important because it will provide useful data for weather, overcoming the limitation of coarse temporal sampling. So the specific recommendation to ESA is to increase the collaboration directly with with atmospheric scientists using ESA methodology. Another recommendation related to DEM or DEM differences was to increase the availability of them and also to have a higher accuracy. So the last one is to obtain high accuracies with a frequent time update to monitor cold environments and indicating that the difference of the DM should have a performance or an accuracy better than available DMs from single pass. And I think that's all. So we had also some seed questions, but yeah, I was going directly to the summary and recommendations. Thanks.
Fantastic, thank you very much. And so next up, we've got the thematic mapping session. So we've got thematic mapping now, and then we're going to move on to AI and machine learning, and then landslides.
So, thank you very much. These are the seed questions we had for the session, and we had after the session we had a lively discussion of about different aspects that were shown in the presentation. So, basically, the presentation had 5 papers or 5 manuscripts. On the first, in continuation to what I mentioned before, people presented the study of differences between DEM, in this case the DEMs generated by TandemX. So basically they were detecting the changes. On the second presentation, we presented a deep study on how interferometric coherence could be used for thematic mapping, particularly for agriculture and for forestry. On the third presentation, again, a presentation on the use of coherence, in particular, in this case, for monitoring disasters and the prevention of disasters. The fourth presentation was presented by the Italian community. It was a joint presentation where they show that there is a joint effort in Italy focusing on different applications on the combination of X-band, L-band, and C-band. Base C-band is Sentinel-1, X-band is Cosmos Skymet, L-band is SAOCOM. So they were showing different projects, different results on different application hazards, monitoring infrastructures, monitoring vegetated areas, and so on. And finally, some colleagues presented again the use of coherence for a very particular application, because it's civil infrastructure monitoring. In particular, they were interested in monitoring the problems on the roads, okay, on the asphalt. So they have currently very reliable systems, but they cannot extend up to large scales and to monitor all the roads. So they were interested into exploring interferometry to detect the changes on the roads. So the emerging topics that we have in the session is that SAR interferometry, Sentinel-1, beyond the main application of subsidence monitoring, they can reliably use to monitor temporal changes, okay, providing information about the different targets and particularly about the dynamics of the Earth's surface. Coherence itself, the amplitude, basically all the papers dealt basically with intensity or the amplitude of coherence. So it's a kind of a complementary product which can be very useful for some particular application, but complementary to what is already existing. Also, in the frame of changes, as mentioned in the previous summary, changes can be used on the difference of the EMs, but the problem is, as explained by the authors, the interpretation of these changes in height is still quite unreliable because they need a lot of ground truth. Okay, so basically, from our point of view, the main message of this session was that the multitemporal series interferometric coherent interferometric SAR can be useful to monitor the dynamics of the Earth's surface. So as recommendation, it has already mentioned here, we need to strengthen the collaboration between the different space agencies just to provide collocated and analysis-ready data. This is the most important thing, ROSEL, Sentinel-1
next generation biomass in order to make the data attractive to other communities so they can put the data into the GIS system and they don't have to know any particular detail about the soil processing. One of the most important things is in terms of coherence, because this was the focus of the session, is to provide geocode, not geocode, sorry, geocode SLCs in order to be able to create coherence on the fly. But some point that was already mentioned by the several people is that it is important to evaluate the compromise or the trade-off between having the SLC in the radar geometry and in the ground geometry. So someone has to make this study the non-uniform number of looks and so on. They were mentioned also in other sessions. There are also a need to promote studies in the theoretical aspects of the temporal decorrelation. We have seen several applications in some sessions. It's well established, the exponential model, but I mean, the exponential model has these limitations, so we need to study if the theoretical models can be also linked to biophysical parameters. Also is important to, again, in this direction of coherence, to promote studies on the analysis of the contents of the information in terms of coherence about the dynamics of the Earth's surface, and also ESA needs to advertise the coherence parameter as important parameter for the studies of the dynamics. I go again to point number 2. We need to make this parameter useful for other people. I mean, we need to put coherence in Google Earth so people can use them directly. Otherwise, people, they won't use it from other communities. Also, as a final remarks, we need also somehow to focus on other applications beyond global environment applications. We need also to focus on the monitoring of civil infrastructure, because they are important, especially of facing the damages caused by the climate change. And finally, as a final remark, all the people agree that ESA needs to keep investing on SNAP software, because this is what makes possible for other people to exploit the ESA and the third-party mission data. Thank you very much.
Fantastic. So next up, we're going to switch around and have landslides first. So if I could invite landslides up to the desk. 2 more session summaries left to go, I think, guys. So.
Thank you very much. Landslide session was a very short one this morning, but very fruitful. I believe 4 presentations covering several test sites. But I would say that this session is kind of summarizing also all the recommendations that I heard till now, because, okay, this is a topic that really relies on a lot of external data and external information. And very quickly, we just summarize also the topics within these 4 presentations in our seed questions. And yeah, I will repeat some of the things that were said already about the coherence. That the session before said that it's very important also to give more emphasis on the coherence and its importance to wider community, but also we want to emphasize or to give more information about the NDVI and amplitude images to support interpretation of the landslides results. Then, of course, because within this session this morning, there was also a study devoted on the potential of the small, the new space constellation. It was very interesting, especially in the wild conditions in Norway. So one recommendation is it possible ESA to launch another small constellation with the free data? It was also mentioned earlier today. And yeah, and of course we were
interested on the topic, are we ready to produce operationally landslides, maps, or services within the ground motion service platform? And the question is that we still need to develop, to go further and further in this modeling. And of course, this is, again, depending on the external information. So we rely a lot on other sources. So we still have a lot of big floor there to develop further, and I hope next Fringe there will be more sessions on landslides. And then recommendation is also, it was mentioned already as well, to push the other agency to share more data, because, and of course to explore the new missions with the different bands. Thank you.
Thank you very much. And so the AI and machine learning session chairs. There we go. So our last summary session, I think we've missed out the data products and services because that chair wasn't here, but we're running ahead of schedule. So.
Okay, so hi everyone. So I will present a short session summary about the AI and machine learning session. Actually, we have been seeing also from in other sessions the exploitation of the importance of machine learning to improve or as a possible alternative perspective when approaching INSAR applications. So in our session, there were 5 papers presented. I was co-chairing with Samuel Bancroft from University of Leeds, and there were 5 papers exploring machine learning for different SAR and INSAR applications. For example, going from deformation of linear infrastructure to displacement signal, INSAR velocity maps, as well as SAR raw data compression and monitoring of the forest state. So very different application, all exploiting in different ways machine learning base. This was, if looking at the poster, so not only related to the 5 presentation of our session, there were many contributions also exploiting machine learning, also in the phase unwrapping problem, landslides, occurrence time, as well as ground line delineation, just to name a few. And also want to mention the OpenSAR library, since the one of the discussions, so the AlignSAR project, since one of the discussion that I'm going to discuss now was also on the importance of the standardization. So a sort of we are having a huge amount of models and also different data, and it is probably a good strategy to try to find a common consensus. Also, first of all, in terms of training as well as of test data. And also on the models that can be exploited for specific SAR, for INSAR application. But the common agreement was that machine learning represents a promising solution to support existing physical-based model for INSAR application, for improving the achievable performance, as well as increasing the computation efficiency or filling the gaps where the existing model failed due to, for example, missing or noisy data. And it is important, as I was mentioning before, the creation of reference data and tool benchmark for machine learning processes. And last but not least, SAR data compression as well as onboard processing strategies play an important role, also considering the increasing amount of data volume to be acquired in the context of present and future SAR missions. So there we also came up with a few recommendations to ESA. For sure, the potentials of ML methods for INSAR applications should be further investigated and benchmarked with respect to currently used physical models in terms of achievable performance and efficiency. Also like referring to the AlignSAR as an example, like at this workshop. So ISA should, in our opinion, support the curation of reference training, label, and also test benchmark data to be exploited by the scientific community. and at the same also benchmark algorithms that are more suitable for specific application and use them as a reference. Also, an important aspect is the come up probably with a standardized data formats to be such that different scientists from different application can better interface with each other when working with machine learning with, for example, complex R data. And the last 2 points, as these were mentioned also in the discussion, onboard SAR processing represents for sure an attractive solution to reduce data storage, probably also higher level architecture, so to derive higher level information, but also it poses challenges for system complexity and the generation of reliable products. So in this sense, dedicated studies should be initiated, aimed at understanding the potential and limitation. And last but not least, SAR data compression plays an important role for present and future missions. In this sense, opportunities for suitable algorithms should be investigated in dedicated studies in the frame, but not only of current ESA missions. With this, I conclude. I thank you very much for your attention.
That's fantastic. Thank you very much. And I think that concludes our summary of recommendations from all the roundtable discussions. So all that leaves me to do is to introduce my co-organizer, Marcus, to come and wrap up the very successful Fringe 2023 conference.
Thank you, Anna. Yes, it's just a time for some concluding remarks. So I can say from my part that I thoroughly enjoyed this week, and I've seen a lot of happy faces and fruitful discussions and collaboration. And I want to thank you all participants and presenters, chairpersons, members of the scientific community for being here and making this a great scientific event. We will produce the workshop report that has the summaries, and also we extract the recommendations for the community review, and we put those up on our website, so you will hear back from us. And we will still liaise a bit with the chairs to get those in good shape. Then I need to thank a number of teams to make this possible, because of course this is a sizable event, so we started organizing this in Esrin more than a year ago, and there I would like to thank specifically Serco team and Ulla and Magdalena, who put hundreds of hours of work into all these programs and sessions, so thank you very much. Second team to thank is the Olli Services team and Ricardo's team, who's done a lot of work behind the scenes and liaising with the Leeds people, so also thank you to them. Then Earth Observation Graphics Bureau did all the fantastic graphics that you see over here, so I'd like to thank them. And then we brought a lot of other teams on site, so I wanted to thank JGB Productions and Jakob's team for doing a stellar work on the streaming. Thank you very much. We also had Fabrizio Pera from Esrin here to help with we had some difficulties in the early days and we got them fixed with his help. That was great. I'd like to thank Euromod for moving this wonderful Sentinel-1 model here and back from Esrin.
Not necessarily back, Marcus.
Oh, yes. Yes, you've always wanted the model, I remember, yeah. Yes, so that was from the Esrin side. Then I, of course, need to thank all the people here in Leeds. I mean, thank you, Anna, for providing this, site pretty much for us. And thank you for providing the volunteers. They made a great work for running the sessions. Thank you for the local AV and microphone support and IT support. So I think in the end it went well. We had some difficulties to iron out, but that was I'm very happy. Thank you. And I think I hope I did not forget anybody. So I think that was about it for the thanks. People keep asking me when is the next Fringe, and my standard answer in nominally 2.5 years. We always have to avoid putting it around the Living Planet Symposium, because that's our main event that happens every 3 years. So I've heard a couple, or more than a couple of suggestions for the venue for the next Fringe. So please come and talk to me if you have a nice venue and a responsible organizer in a ESA member state or ESA member state territory even. Please come and talk to me. And with this, I'd like to close Fringe 2023. Thank you for coming.
Fantastic.
Yes.